Just a really nice little integral trick that might be worth bearing in mind today. Thank you to the person who sent me this. It's really interesting. How do we do this integral then? Well, there's probably a bunch of ways, but we could try and do it. T formulas come to mind because stuff would cancel here. You could try other substitutions, I guess. But actually, there's a really nice way of doing this that doesn't take too long, which is to try and set up this kind of integral where you have some amount of f of x plus some amount of the derivative of f of x all over f of x. Because if you could set this up, then of course you could split this into two fractions, and then the f of x would cancel with the f of x, which would just give you a here. A and b are constants, by the way, so a would integrate to just ax. And then this thing over here will just integrate to b log of f of x by definition. And so we can actually do that here, right? Because we can just set up on the top. What if we wanted a lots of the f of x, this denominator here, plus b lots of the derivative, sine derives to cos derives to minus sine. And now we're just going to, a bit like partial fractions, I guess, just compare this top line with this top line to see what we need. So, well, okay, in terms of sines, we need a sines plus or minus 2b sines to be 0 sines. So that's there. And then we have 2a plus b causes make 1 cos here. And we get this here. And of course, we can maybe double the second equation and add the two together. We'll get 5a is 2, so a is 2/5, and of course b is 1/5. And we can put that back into our integral here, a and b. We can now do exactly the plan that we had, which was to cancel these two guys out after we split the fraction in half, and then say that this is just going to integrate to be 2/5 x plus a fifth, and then log of this denominator here. And that's going to be the entire thing. It's just a quite nice trick that's maybe worth bearing in mind, just in case you see an integral like this. The constants down here don't really matter. If you've got some kind of addition of cos and sine, and then you've just got some addition of cos and sine on the top, it seems to just be a thing that works, which is quite nice. I haven't found another situation in It Works, It Works. We've put some time into thinking about it. I mean, obviously, sinh and cosh it would work for in exactly the same way it works here, but there doesn't seem to be any other situations aside from trivial ones, which are like what you really want from integration tricks, right? Is a way to do it that no other method can do as easily. But aside from very trivial integrals, we haven't found another example of a way of an integral that's actually helped by this method, which is a bit of a shame. Maybe if you do find one other sort of setup in which this idea, forming this kind of idea works really well, then please let me know because it would be useful to know. But otherwise, just bearing in mind this trick for these particular integrals might be worth your while. Maybe if you're taking part in an integration bee in Southwest London today, next week. Maybe it'd be useful for you. Who knows? Anyway, thanks for watching, and I'll see you next time.